Let's go back and look at what Swimwalks did. You'll notice that I did something that perhaps I shouldn't have. I hard-coded usual drunk in this code, so that in fact I have no way to experiment with any drunk other than the usual drunk. Probably not good programming, and fortunately something that's easy to fix. So let's now go over and look at the code where I fix it. So over here we see a modified version of Swimwalks. I've added an extra parameter, D class, short for drunk class. And now when I instantiate it, rather than using the constant usual drunk, I use whatever value this parameter has. Once again, we see the great leverage we get in Python from the fact that everything, including classes, are first-class objects, so we can use them in a uniform way. And then I've made a modification to Drunktest as well. Let's look at it over here in the PowerPoint so I can draw on it. The interesting part is I've added this loop. I'm going to iterate over the three classes of drunk, usual, cold, and E. For each class, I'll start with mean distances equal to the empty list, and then I'll run the simulation as before, getting the average distance of a walk for that kind of drunk. And then, still within this loop, I will produce a plot for the drunk, and I'll use as a label for the plot the name of the class. So we see yet another underbar operator. dClass.underbar name will return the name of the class. And that will allow me to have a legend that tells us which plots correspond to which class. And then there's some boring code afterwards that just produces the plot. We won't bother with that. All right, let's come over and run it. See what we get. Wow. This might not be what you expected. You can see here the top line, the green line, is the cold drunk. He seems to be moving considerably further than the other two, despite the fact that a quarter of the time he's taking a shorter step. This is the usual drunk, behaving as we saw last time. And then the E-drunk seems to be moving kind of like the usual drunk, but not really as far. And in fact, the distance seems to be getting greater. Should we believe that these results are dispositive, or are they just fluke? There is randomness here. They could just be a fluke. Well, over the next few weeks, we'll look at mathematically sound ways to answer this question. But for now, I'm just going to run another trial and see if we get kind of the same answer. So I'll run another trial of 50. Pretty much the same thing. The distances are a little bit different, but the trend is almost identical to what we saw before. Now you can go back and ask, is this what you expected? If not, think about why not. If you think hard enough, you'll be able to come up with some theory, maybe a good one, maybe not a good one.